How's everybody doing today? Oh, how are you doing? Oh, let me get my little slideshow together. Struggle streaming. Hit me one in the chat if you can hear me. Hit me one in the chat if you can hear me. Let's see. That's me. What's up before the billions? Glad you could join me. Let's see. Give me one in the chat if you can hear me. Oh, she can hear it. Y'all see it on there? We'll talk a little bit about AI. You know, I'm a NIST fan, so NIST AI 100 2E 2023. That's a different way to do it. Glenn, I'm struggle streaming. Let me go check on my my LinkedIn. I'm struggle streaming. Let's see. You know how we do. If you got any tech questions or cybersecurity questions, just drop them in the box. Let's see if we got a little LinkedIn going on over here. Let's see. Okay. Check that out in a minute. Let's see. Cool. Ooh. Let's see. Got the notification. About to get started. My bad. Checking on my LinkedIn. I'll be struggle streaming. Of course, I don't see it over there. It said we'll start soon, so sometimes they're about 2 or 3 minutes behind. But let's get going. MGTOW Unit first. Glad you could join us. AI. Basic stuff. Basic stuff, man. Just gonna touch on a little bit. Everybody know I do governance, risk, and analysis, so we're gonna touch on that a little bit with the AI and the machine learning. Long story short is I feel comfortable about everything in compliance. A lot of people have been asking me about machine learning and AI from a compliance perspective, and I was a little thin on that, so I thought I needed to dig in a little bit. So we're about to get into it. Once again, got any tech questions or cybersecurity questions, drop them in the box. We're about to get rolling. Part of that, which is not in the NIST, is from a DevSecOps. Now they got it's usually DevSecOps for development. Now, of course, somebody did the machine learning SecOps, right? So you got the machine learning part, the operations part, then from a security part, cybersecurity part with machine learning and AI, right? Supply chain vulnerabilities. A lot of people are putting AI in everything. So when you send your information to a third party, a separate vendor, from a security perspective, from an AI perspective, do they have some supply chain vulnerability? Models of preventions, and we're gonna dig in a little bit there. You have your model. How do you make sure it's not getting poisoned? How do you make sure it's not hallucinating? Right? How do you put guardrails to make sure nobody falsely trains your model? Right? This governs risk and compliance. And what's the risk of somebody doing that? Then, if you have governance, risk, and compliance, a lot of people calling that trusted AI. Right? We have guardrails, security in there. So then two is, and we're going to dive a lot into this adversarial machine learning. What are hackers trying to do to mess up your model? What's hackers trying to do, once again, the poisonous? What's hackers trying to do to skew your data, right? So your app can give out false information, right? So what does that look like? Boom, boom. I was not. I saw that. I saw that. I don't know about that. The five as jailbroke. Yeah, I did see that. I don't know if I was gonna talk. I seen a lot of other people talking about that, MGTOW. I'll drop the link in a little bit. If you want to come up, we can chop it up about that. But I wasn't gonna really dig into that. I was gonna get our toe wet in AI and machine learning. Let's see. Let's see. Everybody giving a shout out. Shout out to my man Ty. Ty, we need to link up. That was my bad. I was snoozing. Shout out. Let's see. LLL hacking L. Yeah, that was interesting. I think I'm gonna do a separate video on that. That was interesting, and we're gonna talk a little bit about that in here too. LLMs, large language models, attacking other models, and how do you? There's a cybersecurity slide I pulled out talking about once again having LLMs hacking your machines, right? Because it can scan your infrastructure. It could figure out what versions you run. It could figure out the vulnerabilities in those versions, and it could put together, construct things to hack your environment, right? All from machine learning and AI, all right? Shout out to Arnold Schwarzenegger. I appreciate you. Shout out to Terminator, right? So that's where we're getting to. Well, good evening. Cyber from the Fire. Nice to see you. So let's keep rolling. So we're going to touch on the ML ops a little bit. This is the abstract, so I just kind of pasted it all in there. Usually I don't let my slides get this radical, but let's check out what the abstract is. NIST Trustworthy Responsible AI Reports develops a taxonomy of concepts and defines terminology in the field. And I think that's what my man was just talking about. LLMs attacking LLMs, adversarial machine learning. The taxonomy is built on surveying the AML literature and a range of concepts of hierarchy that includes key types of machine learning methods, life cycle stage of attacks, attackers' goal and objectives, attackers' capabilities and knowledge. Report also provides corresponding methods for mitigating and managing the consequences of attacks, point out relevant open challenges to take into account in the life cycle in AI. And two is, you know how we do it. So we're going to talk about the theory on it with the NIST AI. Then we're going to talk about, everybody know I'm an Amazon AWS fanboy. What does Amazon have in their chain machine learning lifecycle to help you block poisoning, help you protect your models, help you deploy your models in a secure way? So we're going to look at some of the services they have to protect your model, right? So we're going to go from data engineering, shout out to before the billions, to the machine part. The data engineering gets all the data loaded, right, and cleaned up so you can run it through your model and your model can learn. And so we're going to look at that particular thing too. Hell, I think I'm going to jump down there, to be honest, because I'm that guy. Let's jump down there. We're going to jump back up, which I shouldn't do, but I do what I want to do. Do what I want to do. Let's see. And so the differences, right? So we're gonna go back up. Oh, let's see if am I showing that on the screen. Oh, let me get that on the screen. So kind of what's the difference among that? And so ML ops compared to DevOps. So the first four they share: code versioning, artifacts versioning, continuous integration, continuous delivery, and continuous monitoring. Now, what is the machine learning, the AI piece? Data lineage, governance and management, experimental tracking, right? Your model's always learning, you tracking and versioning, model lineage, governance and management, retraining strategies, because your model has to continue to be updated. You're going to get new and better data, and people might be trying to skew your data. And the other part of that, model build, deployment, and workflows, right? So let me get back there. So those are kind of the difference, and we're going to dig down into that part. Let's get back up to the top. I just wanted to touch on that. The difference between DevOps and ML ops and what we're talking about learning. So we just kind of peruse the abstract. So let's start digging in. Let's see if there's any questions in there. Shout out to Brother Michael. I don't think I've seen you in a minute. Hopefully all is well. Shout out, definitely one of the day ones. Let's see, numerous way to hack machine. Oh, yep, numerous ways to hack machine learning. So, yep, we're gonna get into some of those. Facts, no fluff. Too lots of function. Too many places to attack. Even the neural shell. Shout out to the neural networks. Shout out to my man Mike V. Definitely, I need to get him on here and interview. Definitely go check him out. I'm always in the clouds checking out the Black Brain Trust. So definitely go check my man Mike V out. Definitely one of the good guys. Shout out to Dr. Finesse, up and coming in the industry. I'm definitely gonna have to interview him on my channel. Young and upcoming guys. Shout out to him. So let's get on back onto this NIST. So many, and I think that's what my man was talking about there. Facts, no fluff. Many advances of development and mitigations against different classes of attack. The report offers guidance and development. So shout out to the NIST AI 100 2E223. The taxonomy mostly widely used for effective tax. We talked about this: evasion, poisoning, privacy attacks for predictive AI. Same thing for generative AI. All right, evasion, poisoning, privacy, abusive tax to generative AI. Attacks against all viable learning methods. Supervised, unsupervised, semi-supervised, federated learning, reinforcement learning. We're going to touch each one of these as we dig into there. Cross multiple data modalities, discussion of potential mitigations and AML and limitations of some of those too. And once again, we're going to dig into there. I just pulled out some of the high-level attacks and some of the high-level mitigations, right? We doing introductions today. We don't want to dig too deep in there. So let's keep going. Attack classification, you see it over there in the model. Attacks in the adversary learning and predictive AI. The attacker objectives are shown in the disjointed circles. Availability breakdown, integrity, and model extraction. So at the top, you see availability. You see model poisoning, energy latency, data poisoning, and clean label poisoning. Right? Then you see there the availability, query access, model control, and training of data. All right. A lot of people are, like my man said, they're attacking you while you training your data. They're poisoning your data while you're trying to train it. Right. And we're going to dig down to each one. But you see there too, integrity, got the black box evasion, clean label poisoning, clean label backdoor. And once again, we're going to touch on a few of those in there. Once again, just introduction. And I would, if you're really getting into it, I would definitely recommend going out and check that NIST AI 100. I thought it was super in depth, and I'll probably do a part two, dig down a little deeper into it. The only way to patch a model fine tuning, which begs the question: what part of ML ops won't be highly technical? We're gonna dig into that MGTOW universe. I've got some of the roles that are inside ML ops. They have security analysts in there, security engineer. A lot of times, the analyst, you just validating what the model's doing from a compliance standpoint. Also, if it's fair ramp, what kind of business are you trying to do with it? Once again, I do a lot of IRS work, so it has to be IRS Pub 1075. But we definitely look at some of those roles and responsibility in there in MGTOW Universe. And I'll probably drop the link if you want to come up. Just in my AI security cert right on top. Oh, that's cool. Definitely gonna bring you up in a second, Mike B. Like I said, I'm just getting my toe in there. So let's keep rolling. See, I'm struggling today. I don't know why I'm so tired. I have 4 days off and I'm still tired. Once again, stages of learning for includes training stages, models learn, deployment stage, when it's deployed, supervised learning. We were going through some of those. Labeled training data is given as input as training algorithm into this training stage, and the ML models optimized to minimize specific function loss. Validation, common supervised learning techniques include classification, in which the predictive labels or classes are discrete. Regression, in which the predicted labels are responsive variables or continuous, right? Regression, you learning, you increasing your labels, you increasing, you're validating as it's learning, right? So that's kind of one of the things I was kind of a little fuzzy on that. Once again, once we get down to the end, we'll look at some of the AWS's services and how they protect those services, and in those particular domains, right? So one of the things we were talking about was training time attacks. Attacks during the ML training stages are called poisoning attacks. In a data poisoning attack, an adversary controls a subset of the training data by either inserting or modifying training samples. Model poisoning attacks, the adversary controls the model and its parameters. Data poisoning attacks are applicable to all learning paradigms, where the model poisoning attacks are more prevalent in a federated learning, where clients send local model updates to the aggregated server, and in supply chain attacks where malicious code may be added to the model by suppliers of model technologies, right? So from a GRC perspective, right, Kaseya's, the bad guys got their code in there. We just did the one where we did the update, shut down airports, shut down data centers, right? Because the supply chain had bad code in it, right, and corrupted. So a lot of the things you see in regular security, you're going to see in the ML and the AI part, right? Keeping your code safe, signing your code, making sure the bad guy is not updating your code. And part of that updating, right, is you sending training data, and once again, you could poison the model or the data part of that. In deployment time, there are two different types of attacks. An evasion attack modified test samples to create an adversarial example, which is similar to the original sample according to certain distance metrics, but alters the model prediction at the attack. The second is a privacy attack, such as a membership inference, and data reconstructs are totally mounted by attacker with query access to the ML model. They could be further divided into a data privacy attack and a model privacy attack. We're going to talk about that once again from an AWS perspective. Who has query? Who has update? What different roles do you let have in there? And two is we were talking about just-in-time privileges. So you can give somebody just in time to be able to update a model in production or in training. Then take away those privileges. So if the hacker gets that particular user's password or information, if they try to log in and update it, they wouldn't have those privileges because we do them just in time for training, development, or if you put stuff in production, right? So those are ways to actually prevent those type of attacks from happening. Let's see those classification, cluster regression, learning how those are used and how to distort all those algorithms can be done. Oh, facts. Nah, you speak the truth, right? But once again, facts, no fluff. We're gonna look at what AWS can to help you protect those, and that's from a security perspective, cybersecurity perspective. That's what we're gonna prevent that from happening. Facts, no fluff. Because we about that life, man. We about securing stuff. But you're right, and I think the point of that is it's a big attack surface, is a big attack vector. So you need to understand those parts and how to secure them, right? So that's kind of why I'm touching on different attacks at a high level. Then once again, we're gonna jump into some AWS service to help you protect those. Give me 1 sec. I drink a little water. So let's talk about the attacker goals and objective. Once again, I just pulled out some high level stuff just to kind of get us a feel. Then once again, we're going to jump into some AWS services, some roles, how to protect against some of these common attacks. Once again, the poisoning, the model poisoning, the privacy part. Once again, from those particular AWS services. The availability attack is an indiscriminate attack against machine learning where the attacker attempts to break down the performance of the model at deployment. The availability attacks can be mounted via data poisoning, where attacker controls a fraction of the training set, via model poisoning, when the attacker controls the model parameters, or energy latency attacks, where via the query access. Right. So there's different ways to attack. And once again, we're going to touch on differences, services to help protect us on that. Which AI did you do, Mike V? If you don't mind saying. If not, that's cool too. Yeah, we hit all of those. So let's keep rolling. Once again, I'm struggling today as always. Integrity violation, integrity attacks targets the integrity of the ML model's output, resulting in incorrect predictions performed by ML model. The attacker can cause an integrity violation by mounting an evasion attack at deployment time or poison attack at training time. The evasion attack requires modification of test samples to create an adversarial examples that are misclassified by the model to a different class, remaining stealthy and imperceptible to humans. Right. So once again, shout out to my man Before the Billions as a data engineer. When you're moving your test data, your data you're bringing in, and from a data engineer, getting that data clean and into a data warehouse, into a data lake, into an operation data store. You don't want anybody tampering with your data, which which is still the same here from an ML perspective, right? And from an AWS, we're gonna put on S3 bucket. We're gonna assign a key to it to make sure it's all encrypted. We're actually gonna do a S3 object lock, meaning once we put it down, you can't change it without actually putting a whole new data file out there, right? So once we validate it and then we check it in, only that version of that data will flow to that model, right? To get a different version to come in, right? And you will see it. There's actually an advisor that okays all the data of the model before it gets into production. So we're gonna sign it. We're gonna make sure it's encrypted. We're gonna check it into a version. So you can't change that version. The only way to change it is you would have to update that version, right? So if that version got updated, we know somebody had to put a ticket in or it was a bad guy, right? So once again, we're gonna talk about how do we protect the data models. Privacy compromise. Attackers may be interested in learning information about the training data, resulting in data privacy attack. About the ML models resulting in a model privacy attack. The attacker could have different objectives for compromising the privacy of the training data reconstruction, inferring contents of feature of the data, a membership inference attack, inferring the presence of the data in the trading set, data extraction, ability to extract data from a generative model, and property interference, inferring properties about the training distribution, and model extraction, model privacy attack, which attackers aim to extract information about the model, right? Because two is really model is the proprietary data, right? Google search is a proprietary search. These models are the key to your company, right? These are proprietary information you use to make money, training models, training financial information, training healthcare information, trying to come up with inference or insight into data, right? And that's what these models are done, right? So that's going to be the new gold out there is these AI models, and you train them to come up with some, expert analysis. It could be financial data, medical data, mental health. I went to a seminar at AWS here in my city, Indianapolis, and they were talking about healthcare data and using AI to predict people's mental health. When should they check themselves in? When should they ask for help? And if you need to do an intervention, right? So this doctor was actually doing that, and it was using the camera on your phone, using the speed of your speech to feed into this algorithm. So my thought is, how would I secure that? Which parts would be secure? So from an AI and machine learning model, I was a little thin on that. All right. So once again, we were talking about the training data control. The attacker might take control of the subset of your training data. We were talking about that. Model control. The attacker might take control of the model parameters by either generating a Trojan trigger and inserting the model by sending malicious local model updates, or testing data control. The attacker may utilize this to add permutations to a test sample at model's deployment and perform an evasion attack to generate adversarial examples or backdoor poisoning, right? So you got the training data control, the model control, and the test data control. And I think that what my man Fluss was talking about, there's so many ways to attack in AI machine learning, right? So you got to have your security up to date and what you're going to do inside there. So that's good. That's true. Using blockchain, like you said, because once it gets checked in, right, the only way to do that would be to, and I think that's kind of what they're using their S3 bucket. It kind of gives you that version of blockchain, because you have to create a new node and you can't change that particular node you created. Fluff, but we dig into that. That is a good point. No, that's true. I think they're using S3 lock, which is kind of a poor man's blockchain. But no, that makes sense with the blockchain. And once again, once we get to the AWS portion, we'll dive into that blockchain piece. That's interesting. I do remember you saying that, and I think that's where you start once again putting those technologies into the place they needed to go. They need to be. And the other part of that, they were talking about label limit. The capability is relevant to restrict the adversarial control over the labels, training examples, and the supervised learning. Clean label poisoning attacks assume the attacker does not control the labels of the poison sample. A realistic scenario, while regular poisoning attacks assume labels control over poisoning samples. Source code control, we talked about that all the time. The attacker may modify source control of an ML algorithm, such as the random number generator or third-party libraries. Query access when the ML model is managed by a cloud provider using machine learning as a service. The attacker may submit queries to the model and receive predictive either labels or models. Capabilities used by a black box evasion attack and energy latency attack and our privacy attacks. Right, so you can do the queries. You can kind of overload the queries, or sometimes the queries are used to train a machine learning. So once again, you could do false queries, and once again, change the privacy or the prediction of the labels while you're doing the queries, right? So those are some of our standard box, and we usually do this from testing, right? A white box test, a black box test. So it's kind of the same thing, right? White box assume the attacker operates with full knowledge. Black box attack, the attacker assumes minimal knowledge. Gray box attacks, they have a range of box attacks that capture adversarial knowledge between the black box and white box, meaning they have some understanding of your model and what you're trying to do, right? Which makes it easier to attack. White box usually means somebody internal is usually attacking because they kind of know your whole infrastructure and kind of how you do it. But I take that back a lot of times when you use stuff like Azure and AWS, they have their standard best practices. So you're going to use those best practices. So everybody's kind of using them the same way. But then it's the data and what you're trying to do, but the process of it. And we'll look at their standard process coming up. Some of the adversary attacks and which type of data you're using, what multimodal data you're using. You could use image, text, audio, video, tabular data, PDF. There's a lot of data streams out there, right? So, and this is from a cybersecurity perspective. The first poison attack was discovered from a worm signature in 2006. You could use spam email classifications in 2008. Since then, poison attacks has been shown for malware classification and malicious PDFs, Android malicious app classification. Evasion attacks against the same data have been proposed as well. Poisoning unsupervised learning. Once again, at the bottom, industrial control system, SCADA, supervised control, right? So you're talking about water system, nuclear power plant, electric systems. You see it at the bottom, power plants, nuclear, fossil fuel, renewable energy, water treatment. So all those are open from attacks. Again, what's my man said? No fluff was with AI and ML, you can attack a lot of stuff. And two, if you dig in there, these numbers are different segments and different attacks, so they classify them. And once again, I probably do a level 2 of this and go a little more deeper. Once again, I just wanted to touch on some of the high level attacks. Once again, from my knowledge, I was a little thin on that. I got to catch it with Mike V. I was a little thin on that, so just kind of getting my toe in the water. Physical realizable attacks, these attacks against machine learning systems that becomes feasible in the physical world. One of the first physical attack in the literature is attack on a facial recognition system. The attack can be realized by printing a pair of eyeglass frames, which misled facial recognition systems to either evade the detection or impersonate another individual. Proposing an attack to generate robust under different conditions, we result in an adversarial example that can evade vision classified in various physical environments. Right. So one thing they were doing was the machine learning. If the sign said 30 miles an hour, the car would drive 30 miles an hour. Somebody put some black tape and said 80 miles an hour. The car saw 80 and started speeding up. Right. I think it was a Tesla attack. They were reading signs and it would go the size of. So they just took black tape and just changed the 3 to an 8, and the car sped up to 80 miles an hour. Once again, that's a physical attack, right? Not super sophisticated, right? But just attack on itself. A generative. A lot of times, a lot of companies I work for that were big companies. If you said generative AI, you had to go in front of a board of people, right? So, what is generative taxonomy? It's a branch of AI that develops generative models with the capability of learning to generate content such as images, text, and other media with similar properties as their training data. Generative AI includes several different types of AI technologies with distinct origins and model approaches related properties. Generative AI networks and generative pre-trained transformers and diffusion models. Recently, multi-model AI systems have started to combine two or more technologies to enable multi-modal content generation capabilities. Right. So AI generative is a branch that develops models with the capability of learning and generate other content such as images, text, and other media. Right. So I think a lot of companies were getting nervous of the generative part. Right. Once again, I see a lot of policies and procedures talking about generative AI, talking about going in front of a board, talking about getting that approval. Somebody reached out to me. They actually had a separate security team that was looking at generative AI models. Well, I thought that was interesting, right? So that security team was digging more in depth into that. All right. So once again, it's the same thing, but this is talking more about the generative systems of that, similar to the predictive AI. But once again, it's generative. So you see denial of service, indirect prompt injection. We talk about prompting and engineering, especially with um, setting your prompts up correctly. Then once again, you still got data poisoning, prompt injection, integrity, misaligned inputs, indirect prompt injection, target poisoning, data poisoning, backdoor poisoning. So those are all of your different attacks. If we're talking about, MITRE, I'm sure if we go to MITRE, if they're not there, they will be there for AI attacks. I'm sorry, generative AI attacks and predictive AI attacks. These are what MITRE used. Then MITRE, once again, to tell you how to secure it or tell you how to look at it to see if those attacks are being taken out against your firm. Yep, I remember the blockchain. Learning this, you can attack robots. Facts. No, you're right. Generative AI can be attacked with two sources of data being up. Facts. We're kind of looking up there, right? Multiple ways to attack it. Once again, I'm just sticking our toe into it. Check out to my man joining us. Appreciate it. Attackers' capabilities, novel attacker capabilities enable generative AI. Once again, we talked about the training data control, query access many generative AI models in their applications, retrieve augmented generations are deployed as cloud host services with access control through API keys. In this case, the attacker can submit queries to the model to retrieve the output. In generative AI, the purpose of submitting attacker-tuned inputs is to elicit a specific behavior from the model. This capability is used from prompt injection, prompt extraction, and model stealing attacks. Once again, source control. The attacker may modify the source code of your machine learning algorithm. Resource control, the attacker might modify resources, documents, web pages that will be ingested by the AI model at runtime. These capabilities use an indirect prompt injection. Because if you're getting data from documents and web pages and I feed you false data, right, that's a form of poisoning. But of course, here they're calling it an indirect injection attack. So there's different ways because, like my man said, you taking in so many inputs, once again, for learning some way. So how do you secure all those inputs and make sure they're good? Right. Then here's the big part is, and we're always talking about supply chain, right? So the AI supply chain attacks and mitigating studies on real world security vulnerabilities against ML shows that security is best addressed comprehensively, including software, data models, model supply chains, and network storage. Since AI is software, it inherits many of the vulnerabilities of traditional software chains. However, many practical generation tasks begins with open source model or data that typically been out of scope for traditional cybersecurity. For example, ML repositories target large software vulnerability exposures, including TensorFlow and OpenCV, right? Because once again, you're using a lot of open source product, a lot of open source data. So if that data is tampered with, your model is going to be flawed, right? So once again, how do you protect that? Once again, we're just going to hit these at the high level. Mitigation varies. The defense strategies have been proposed to prompt injection that provides measures. Training for alignment model provides continuous to create a built-in mechanism by training with strict forward alignment. Prompt instructions and formatting techniques. LLM instructions can cue the model to treat user input carefully. For example, appending specific instructions to the prompt, the model can inform about subsequent content that may constitute a jailbreak. Right? Detection techniques models provide continues to create built-in mechanism by training with strict backwards alignment via evaluation of specific craftically benchmark data sets or filters that monitor input of it. And we're going to dig into some of these more a little bit, but these are ways to for mitigations to stop those different types of poisoning, model alignments, and different attacks we saw in that particular graph. So once again, it was kind of eye-opening to me. So what's up, Jim R? Let me do. So let's kind of dig into some of the services for that and what they look for. I dropped the link if anybody want to come up. So let's jump in there. So ML ops, what is ML ops, right? Machine learning operations, similar to DevSecOps, or a set of practices that automate and simplify machine learning workflow deployments. Machine learning and AI are core capabilities that you can implement to solve complex real world problems and deliver value to your customers. ML ops is an ML culture and practice that unifies ML application development and system development operations, right? This stuff, the DevSecOps in that version. That's a good point. Hopefully, they would have one source of truth for that AI detection. But yeah, that's true. You don't want the false learning to start making false positives, or the other way around. Stuff that's false that they say is good, right? So, no, that's definitely true. Let's keep rolling. And here's if you see it, of course, AWS machine learning lifestyle kind of detailed view. Your data prep, you're talking about data aggregation, data wrangling, feature engineering, data balancing. We got to clean, normalize the data, regularize, make sure it's unbiased, detect biases, transformation encoding, joining. If you have a feature stored offline, training and tuning, right? This is your pipeline. Algorithms, model training, model metrics, hosted local code artifacts, model artifacts, uh, artifact lineage, deploy and monitor, right? Model testing, model deployment, batch or hosted. The inference gets to your user, right? Got AWS with the smiley face, using some dashboards, but that's kind of a high level ML life cycle. But we're gonna get a little more detail. Um, if you go out there, there's a whole channel with ML Sec Ops. And these were the 5 pillars, and we looked at those earlier, right? Supply chain vulnerability, model preference, governance, risk and compliance, trusted AI, and adversarial machine learning, right? So that's what they believe were the 5 pillars. And we looked at this, right? DevOps, then these are the additional 5 things for machine learning, and I put AI in there, right? We looked at some of those on that side: data lineage, governance, and management, experiment tracking, model lineage, governance, model retraining, model building, and deploying, right? Because we want to stop it from poisoning the model or retraining the model or getting the code to the model. And like you said, if you get cancer, start overlooking cancer when you got it, or giving false positives, or have you on a treatment you don't need, right? So that's kind of where we got to really lock it down from a security perspective. And from AWS, these are the 6 things they like: data preparation, model build, model evaluation, model selection, deployment, and monitoring, right? Then at the bottom, you see it: MLSec, identity access management, the IAM controls, right? Who gets to see what, and what that would look like. So once again, from your data pipeline or ML pipeline, data preparation, model build, model evaluation, and model selection, deployment, and monitoring. Once again, here's the link. I dropped it down if you want to come up. Just click on that and come on up. It's up to you. No pressure. Once again, I was just trying to I need to, I guess, reach out to my man Mike V and get an interview so he can coach me up a little bit. So I was just trying to get my toe wet in the machine learning AI type pipeline. A lot of people are adding that into their code base, into their operation, right? So from AWS's view, this is their roles and responsibility. You see the data preparation, and data model. At the top, you have your data engineer and your data scientist. From the model selection, you got your DevOps engineer and your machine learning ops engineer. And at the bottom, you have your security engineer for data preparation and model build. Then your security analyst goes through the whole thing, right? Because you're validating, right, the whole process, especially if you're doing IRS or C or something like that, right? Then your model approver, right, wants to make sure hopefully there's no poison in your model. Then you have your governance officer at the model to make sure everything is in there. Let's see who came up. Oh man, hold on, I'm struggling a little bit with my new update. Let's see. Where is that? Okay, there he is. What is up, man? Where have you been?
I've been I've been like everybody else.
Nah,
Everybody, like everybody else. Right now, everybody got that Spider-Man sense.
no, I feel
Yeah.
you, man. I
So
feel you.
I basically I've been doing some stuff, getting some certifications and
No,
just.
man. So yeah, man. Chime in. You the guy needed to get up here, man. I'm just getting my toe a little wet. What you got to add to it? What you got to
In all this, every vulnerability exists. Again,
Yeah.
from the data preparation, that stage is also vulnerable,
Mm-hmm.
especially when you're gathering all the data. You can poison that. You
Oh,
can
I got
say
it coming up. I got it. Keep going. I'm gonna just show the slide
you can
while you
poison
talking.
that, and also building the model itself.
Yeah.
For instance, the like most LLMs and all that, it's neural networks,
Facts. Facts.
and most people don't understand the black box. They say
Yeah.
black box, but you can poison that without any knowledge in that.
Facts. Facts.
So especially right now people are building models. Most people who I know building models don't understand what they're building. They
Facts.
just take models and just shove it in, and they say, I'm saying, do you understand the complexities of how this is? Because if you understand the complexities, you can understand how the attacks happen. But most people now, they have a cookie cutter model. So AWS just gives you a model,
Facts. Facts.
and nobody understands how it works.
Hmm.
Nobody understands how I can put bias in your source data,
Yeah.
and now your your model is spitting something ridiculous, but you're confident with it because you believe you've done it right. But I already know, and I'm monitoring your efficiency rate, your
Hmm.
accuracy, and all that. And I know I poisoned your source data, but you getting your efficiency rate is 80%. Your recall, everything is 98. But I already know it's false because I already poisoned your source data. So you're training on wrong data already. So you are confident in that. So problems occur in such places like, again, the hospital. When I train your data, when you training your model to detect cancer cells, and I
Yeah.
poison that and say a lot of false negative or false positive, but I'd say you take that false negative as true false as positive. You don't take it as false negative. It's I just poisoned your data. So now all your false negative is true positive. So you're
Yeah.
taking that and saying, okay, it's true, and your recall rate is high and everything. It's beautiful. But I know that now your models don't detect cancer cells. And sometimes it I train it to detect not to say there are cancer cells in there. So now you're going to the hospital getting cancer treatment,
Yeah.
poisoning your own body.
Yeah.
But again, that's why I said most right likely nobody's using algorithms as a source of treatment. It's basically a second opinion
Okay.
or even a third opinion, but nobody's relying solely on algorithms to make a decision. It's an assist.
Yeah.
But again, even right now with robotics, with reinforcement learning, I can teach. That's another risk. You're teaching your robot to learn from the environment they're experiencing, and you're providing the data of what the environment is doing. So if I'm going to teach my robot to go through a maze, and and I change and I go there and poison what he's learning, I change the maze itself and make it either ridiculously hard or train it where it's false. Now it's being trained on false data. And now, when you put it in real life situations, you have problems like the robotics in terms of the Tesla cars
Yeah.
because they trained it on data, but they didn't expect unusual circumstances that might happen.
Yeah.
So these are issues that come from not only training from with the source data, but even not thoroughly understanding how ML ops work or how machine learning, how training a model actually works.
Yeah. Yeah.
These are where the problems come in, and I can tell you all the security. There are a lot of security issues in this.
Oh yeah, 100%. Give me 1 second, real quick, engineering. Kind of give me 1 second. So if you see this graph, right, Amazon, like my man engineering cam, they give you SageMaker, which give you a lot of these
SageMaker.
pre-built, yeah, pre-built algorithms, and sometimes like engineering, they might not be 100%, but they get you started, right? That could be
Yeah.
good and bad. The cool thing about this chart is for data preparation, it kind of gives you the common things you should use for AWS, right? KMS keys, make sure it's encrypted. Amazon S3, like my man said, he was talking about blockchain. This kind of gives you blockchains because once you check it in the S3 bucket and you put a lock on it, you can't change the data unless you create another version, right? Then we saw the user there, the approver, would have to prove the new version of the data to go through for training, right? So there's just different things you would put on there. Amazon Inspector, the model selection S3 bucket. You see S3 bucket in a lot of these.
You
You
see,
know, the
yeah.
monitoring was CloudWatch, the SIM, and all that. So these are the tools, and I got videos on kind of each one of these individually, and we're gonna start digging more into the AWS tools. Go ahead, jump in back in there,
So
Engineer Cam.
remember when I was talking about blockchain, the only way to safeguard and analyze the data. So now you safeguard So your initial data you use to train the model is now safeguarded.
Right, right.
Now you can train it. Then if there's a problem or something, you can then analyze, okay, what's going on with, if I'm seeing something wrong and there's a new data set, because again, the model, you always have to train with new data sets,
Yep.
because the model always has to be new. Again, the environment is changing, so the model has, so now you're using your old data and making sure you analyzing any kind of change or interference, especially with the parameters. What kind of parameters did they change the parameters in there? Why am I using maybe I'm using a parameter to decide if I want to predict the housing market, and I'm using GDP. Somebody changed that parameter from GDP to inflation rate.
Right, right.
So why is inflation used? Why not? I used in the first one I used GDP, and this one they changed it to inflation rate. Then that parameter has been changed. Why did it change?
Yeah,
So
yeah.
that detection, the ability to detect it, that's why I said using that blockchain, which AWS is using, encrypting your source data and be able to analyze that to know what's been changed, either in the parameters or the data itself. Especially when you're doing LLMs, large language models, and natural language processing. You want to know if there's any change, especially with the new large language models now that utilize transformers. You want to know what's actually being changed,
Yeah,
especially in the source data.
yeah,
And that's the key. The encryption, which I talked about a long time ago, is
yeah,
that key. The
yeah,
encryption of that source data and encryption of it, so you can now analyze what's been changed during that
yeah,
situation.
yeah, yeah. And they talked about that inside the NIST, like you said. One of the attacks was changing parameters and the model parameters, or the data parameters, or the labels were getting parameters. Like you said, there's a lot of parameters to attack inside of
So yeah, you
yeah.
can change the data set and all that
Mm.
parameters, all that, and also you can go into if you understand the mathematics behind it, the loss function, you can change, you can change a lot,
Yeah.
and you can give a real, you can mess up a model where now it's basically useless, and either it's doing something wrong or you. But if you, that's why I said, if you wanna understand the security around this model, you have to understand how the model works
Mm-hmm,
and
mm-hmm.
how and understand that again. What I've seen right now, everybody's just want to use the cookie cutter way,
Yeah, yeah.
but they don't want to learn how these models are being produced. Why you're using a convolutionary neural network rather than, or using a transformer system rather than a recurrent neural. Then understanding all these basics stuff, not basic, but understanding these stuff, understanding even the data engineering part is difficult. It's another
Mm-hmm.
attack point.
Yep, yep.
Transferring when you want to create and put your whole algorithm into production, taking from creating an API for your algorithm. That even that whole spot is even dangerous. Even how to get your source data into the algorithm to continuously train the algorithm. It's an attack vector in data engineering. Your CNI/CD pipelines. That's an attack. So, in what I normally see is the attack vectors are either the data engineering side or the data science side.
Mm-hmm,
You
mm-hmm.
did attack how the data is being transferred in building your models, the pipeline and all that, or you attack the model itself. So there are two attack vectors that are generalized, either the data engineering side or the data science side. And that's it.
That makes sense. Let me get Shango in there. Thanks for that, engineering cannabis. But yeah, like you said, it's a lot of tech. Shango, go ahead and chime in. Am I saying your name right?
Yes, how you doing, PBO?
I'm
I'm
doing
just
all right.
listening. I'm
Okay,
just here to
okay.
listen and learn. Yes,
Oh,
sir.
that's cool. That's cool. Let me know when you want to chime in. You good? You good?
All
Uh,
right.
so this what engineering cannabis said, strictly data poisoning. These are some of the things that AWS. Everybody know I'm an AWS fanboy. I got a few AWS things, but like he said, encryption. AWS uses the AWS Key Management Service to essentially manage the keys to encrypt and decrypt training data and models with AWS managed keys, or you can manage them yourself or custom manager keys. Then, like once again, engineering was talking about immutable storage. That's kind of their blockchain version that you can do straight in the S3 bucket for your data lake. Amazon S3 object lock can help prevent Amazon S3 objects such as training data and model data from being deleted or overwritten for a fixed amount of time or indefinitely. And two, we want to have an Amazon backup because if we find out somebody's been messing with our data, we can pull it from backup. That could be the model, the data, the programming language, anything that was in those 6 parts. Then the other part of that is data exfiltration. We can use AWS Network Firewall, Amazon VPC, or a private link. You can define strict AWS Network firewalls and VPC policies to prevent movement of data in and out of a VPC. So if you're supposed to connect to a certain API on the internet or an API inside AWS inside of a different VPC, you can say only coming from this internal IP address, only coming from this public IP address on the internet, right? So we can start locking down our data, locking down our transformation, encrypting our transformation. So only we know we're only getting it from gold source of an API, gold source of data, or even if we're getting it from a SFTP server, we can say only these open IP addresses can attach to that particular data source, so we can get it. Then once again, AWS privacy link means we're doing it inside our Amazon VPC to SageMaker. We're not going out on the internet. We all keeping that internal within that AWS, and we only looking for AWS's certain IP addresses, right? Like Engineering Cannabis says, there's a ton of ways to attack it. So hopefully we're locking it down and only moving data from verified IP addresses, verified website, verified API. Right, we can sign off on all of that and hopefully check those boxes from a GRC, compliance, governance, and risk, right? Controlling that. You want to chime on anything on that, Engineering Cannabis?
So this is great in terms of the lockdown, but there's some other aspects in this.
Oh, facts.
For instance, this is again just one way. The
Mm-hmm.
systems engineering aspect, and
Yep.
meaning,
Mm-hmm.
so for instance, they talked of queries, so SQL databases, all that attached to
Mm-hmm.
an API system, attached to a SageMaker, attached
Mm-hmm.
to maybe a Tableau. All these systemized, these are systems that you can also attack points.
100%.
So this is good for the ML ops, the model and all that. But what of when the model's attached to again a Tableau
Mm-hmm.
or some other aspects of it? That okay, for instance, that let's look at we want to get data from IoT. What
Mm-hmm.
happens when you have IoT data that's being transferred live to your model that's being trained live?
Mm-hmm. Mm-hmm.
How did you is that system going to be locked with an encryption with the IoT system?
Yeah, you can. But yeah, and I could bring that up real quick. But once again, you're correct, but you got to identify to make sure it's locked down. But Amazon has, I think it's IoT Greenfield, and in those IoT, each one of those has a specific IP address. So you can say only this IP address coming from. But we know those could be thousands of IoT.
So you see, that's what
I'm
I'm
right there
saying.
with you. I'm right there with you.
So
But you can, yeah. Go ahead, yeah. But you can't.
that IoT system attached to what I'm talking about.
No, I do.
IoT
I
system
know. Yeah. Go
that
ahead.
data driven IoT system
Yeah,
that you're
yeah.
collecting data. For instance,
Mm-hmm.
if I'm trying to go walk in Africa and trying to get data to treat pregnant women or anything, or I want to treat somebody, I'm taking data from them immediately and
Mm-hmm.
transferring to a model, and that
Mm-hmm.
model is making predictions or analysis on that.
Mm-hmm. Mm-hmm.
How trustworthy am I on the IoT system that it's being transferred in there? And then it's if it's encrypted, how's the encryption really verified in terms of that?
No, I'm with you.
So all these, it's in terms of the model is great in terms of the encryption, and
Mm-hmm.
that's one part. But the system itself, it's a system that's complex and ever
Super
changing.
complex. Facts. Super complex.
It's ever changing. It's not again, especially this is what I'm because I've dealt with a lot of models. When the human aspect comes in play, that's where the problem comes in because
Okay.
we as humans produce different data in different
Mm-hmm.
avenue and it's
Mm-hmm.
ever changing. So are you going to be always encrypting an ever changing data process?
Yep. Go ahead.
So how is that going to be verifiable?
No, I'm with you. I'm with you.
So it's this is where I'm coming in terms of AWS is looking at encryption in terms of the model itself, but the system encryption, it's a big part of it, especially when you're dealing with a human element in it, where the data is ever changing, ever dynamic. It's, I mean, again, for instance, the one of the big look. Let's look at the economy because again, but look at the economy, and we want to make a prediction on how the economy works. For instance, we want to know the influence of, let's say, the oil in Russia with the war. Nobody could predict the war and all that. So these kind of data that's so dynamic, how do you on ground collect all these data and say it's feeding into an algorithm to make predictions on what might happen on the ground? So it's ever changing. You can't verify where the source data is, and that might poison your ML model itself. So these are the issues that come in. How do you, as a system, how do you verify all these data sets coming in a systemized way, not just a model, meaning it's coming, the data you can get from anywhere. But how do we verify that this data will not poison that? And it's changing. It can change every second, it can change every minute. How do you then verify all that? That's where the problem comes. How do you verify that these data sets are not don't hasn't been inflicted with biases or something in there?
No, that's true.
And it's changing. So that this what they're doing is for more of a not more of a dynamic data set, but more of a structured data set. Meaning we know what data is being used, we've captured it, we know it's not going to change, so we can then verify when the new data is coming in, we can verify that that new data. But if you're dealing with a dynamic system that changes every day, for instance, in a war zone, the data changes every minute. How do you verify that?
No, that's true.
Or in an environmental issue, or in a hurricane or something disaster area, how can you verify something that's coming out so dynamic in a systemized way? So again, these are the stuff I've been trying and playing around with.
Yeah, I don't know if you can see my screen, but you're right.
Yeah.
AWS has a IoT device defender, so they've been trying to shout out to AWS. What they do a lot of times is, I think they work with so many different companies, and like you bringing up stuff, they try to have solutions that solve them, right? So AWS now, like you said, it's so dynamic, but they do have a lot of things. What you said, they got encryption, they got the audits, the security posture of the IoT device, easily mitigate security issues. So once again, AWS, they try to make it easier, but sometimes when they have that complexity, right, engineering cannabis, they had some stuff you might need to know. But go ahead on that. So,
So understanding not only the data engineering side in terms of pipelines and how the data flows into the system, and also understanding how the algorithm actually works in
oh,
terms of
fine, fine.
what false positive, what recall, precision, accuracy the algorithm gives you, and always be able to have that testing mechanism in there. That's one thing that I'm looking at companies now, having that testing mechanism in there that tests the actual output of these algorithms in there and verifies that, again, you don't have problems in terms of with the source data itself. But again, that's where poisoning and all that could go. But again, there's a lot of issues in terms of data bias and all that. Even data bias alone, it's a huge problem, and it's not only a huge problem in terms of I'm seeing research papers that it's a huge problem.
Oh yeah,
So it's an ongoing problem, but it's an ongoing problem that's being tackled.
no, that's
But
true. Let me read this last slide real quick, and then kind of. But like engineering accountants, we say once again, Azure has some stuff, AWS has some stuff, Google has some stuff. And like engineering cannabis is AWS tries to make it easier with their Sage Maker for ML Sec Ops. But like engineering cannabis, sometimes it's hiding the algorithm from you, and sometimes you don't know the inner workings of the algorithm. You're actually trusting AWS. But once again, at the top, we talk about application and network protection, authentication and authorization. Data protection, we were just talking about that, the KMS keys, using the S3 file lock. We could put a time on it. We could just say, hey, If you change this data, you need to create a whole nother data set. Then with the version, and I'm gonna bring back up the roles. The approver would have to approve the new data set. Threat detection and incident response. Engineering cannabis just talked about how do you monitor stuff and keep a track of it. And Amazon gives you a plethora of things. Amazon Guard Duty, Inspector, Detective. They got a security lake, track and trace audit of your API calls, data access, interaction. And once again, too, they're big things, compliance. Most of these AWS services has been approved for HIPAA work, PCI, SOC 2. I'm a FedRAMP guy. So AWS gives those tools so you can make that federal money and that state money. What's up, B2B? I'm gonna let you chime in. I saw you just come up. I just scared him now. What's going on, B2B? Let you chime.
Hey guys, how you doing?
I'm doing all right, man.
Yeah, man, it's great to see you guys up here. Hadn't heard from Engineering Cannabis in a while. Glad to see you up here.
Yeah, I was asking where he been, man. Where you been? I was asking where he been.
Right, it's been busy, man. It's been
Yeah, it's been
busy for
busy.
everybody.
It's been
Yeah,
busy.
it's been
So
busy.
yeah, but no, it's been busy and also been, especially in the area of data and all that. It's also been innovative in some areas, especially
Mm-hmm.
with AI and generative AI and large language models and all that good stuff. It's increasing, even though I'm seeing a lot of people in terms of layoffs and stuff. But in terms of the data side, I'm not. I'm seeing a lot of intuitive investments in terms of AI. And when
Oh
I
yeah.
say AI, generative AI, understanding the applications, understanding from the healthcare side to logistics. I've been so busy with all that, even especially in the financial and economic side
Mm-hmm.
with the use of quantum technology, which I've started studying and researching
Uh-huh.
to.
Did you see the article about Google investing in quantum
Yeah,
technology?
yeah. And I did,
Yeah.
because again, like right now I'm looking at the neural networks for quantum technology, and
Mm-hmm.
how it's being trained on that. And I've started looking at all that, especially now we're talking about that attack vectors. Now you have to then go into the quantum side in terms of understanding the attack vectors, because now
Mm-hmm.
the data sets, the the new data sets in terms of now will now be, the source data is now won't be regular ones and zeros. The new
Mm-hmm.
quantum data sets will now be different. So it's
Mm-hmm.
not qubits. So now you have to understand how to then poison that. So it's interesting, but it's fascinating. But again, it's a field that's always grown. But
Yep.
it's not without its
Oh shit.
problems, especially with security. But again, data engineering is a big part of that, especially the pipelines, understanding how the data lakes and how connection, especially in data engineering side, how the
Mm-hmm.
connection in terms of systems, from getting data from data lakes, from SQL databases, from all that, and transferring it into your whole model. Because again, you have to continuously train your model. So taking all that data sets, transferring it to a whole model, and continuously train that model to production, and again using SageMaker to create an API system for that, and then getting a result and making sure that result is even accurate enough. And it's a huge undertaking. And with that, the expertise, especially with that, is kind of limited, especially in machine learning. And when you start going into quantum, it's very limited. And we need more people in that area. But again, even the data engineering side too. So it's
Mm-hmm.
interesting. It's really interesting.
Yeah, and it's actually pretty interesting because I have a lot to bring up because I went to Microsoft last month for a meetup event with the AI tinkerers, and they were discussing a lot of the AI tools that they were using. A lot of smart people working on some big problems over there at Microsoft and trying to figure out how businesses can gain more value from this new AI wave. Because and I asked the question I'm going to ask you guys as well is I read an article about this. They were talking about how uh, there's a difference between generative AI and predictive AI, and which one provides more value to organizations when it comes to revenue.
That is a loaded question. It depends. Again,
Hmm.
like I said, with everything, it depends on what objective is. That's the first. And again,
Hmm.
that's one thing I always ask in terms of dealing with models, is to squarely define what the objective is. So that question is as general as possible. So
Hmm.
it depends on what company it is. So, for instance, if you're looking at a financial company and you want to determine in the next 12 years what, like JP Morgan, what investments do you need to invest? Do you use a generative model or do you use a predictive model? It depends on what they want to invest. If I use a
Right.
predictive model and say you need to invest, for instance, in the oil market, and for Russia, right now, it's not a good sign because Russia is in the war with Ukraine and everybody, there's an embargo and all that. But over time, if I change the variables and say maybe Russia now is in peace with Ukraine and everybody embargoes were lifted, when do you think that the prediction is when do you think that might happen? The objective is when do you think the Russian oil might be more lucrative in the next 20 years? Can you predict that scenario? That's again, that's defining an objective, and that
Hmm.
objective makes that predictive algorithm more mostly utilized
Hmm.
compared to saying I want to use a generative model to predict something. I won't want to use that for using to predict Russian oil and all that. So it depends on the objective. So having that saying which one is better in the long run, it's not conducive. The models are dependent on the objective. If you
Hmm.
clearly define what the objective is, then you clearly define what models you need to use. It is a generative or a predictive model. So it just
Right, and that
depends. It just depends on
and
the.
and that's pretty much how it is for the majority of computer science in general. It's always it kind of like it depends,
Yeah,
because it's a science, but it's also an art to it,
yeah.
right? And
It's
it really depends on the business use case.
yeah. You're a
Um,
human. We're dealing with a human. We're humans, and the one thing we say is chaos theory, and everything changes. That's one thing I always say. And I hate dealing with human aspects of modeling. I hate that. I like dealing with structured where I can say, okay, this is going to happen. But when you put a human in it, it basically murkies the water out. For instance, if I want to predict how a plane, when I want to predict if a plane is going to be a propeller plane today or predict it's going to be a propeller plane tomorrow, if a human is interacted like a mechanic, that just muddies up my model because I don't know what the mechanic might feel like. He might want to change that propeller to something else tomorrow because of that human involvement in there. But when that human involvement is out of it, I can just predict, yes, this is going to be a plane tomorrow because the human aspect is not in there. So that's what I'm saying. Once the human is in there, it murkies everything. And then you have to then look at every variable and scenarios. And this is why I love quantum computing because it's faster to see where those scenarios
mhm,
come into play. But with traditional, it takes a little bit of time. But again, when you ask that question, beautifully asked, but because a human is involved, it murkies everything up.
mhm,
That's what the problem. Once a human is involved, the emotion part that comes in, everything comes in. And now, so for instance, even simply predicting what a human will eat in the next 3 hours is difficult because, again, perception, feelings, everything is involved in that modeling. It's a complex model. You think people say, "Oh, you can predict what someone's going to eat tomorrow." No, you can't. The person might be
mhm,
watching a Burger King commercial and decide he wants to go eat Burger King, or he sees a good he smells a good steak while he's going or barbecue while he's going and says, "Okay, I feel like eating barbecue." You
mhm.
can't
Or his
predict.
girlfriend calls him or
Or his
something like that.
girlfriend calls him and says, "I'm breaking up with you," and like, damn, I'm gonna go have some drinks rather than eat. That's the
Right.
human aspect of it. It's so complex. It drives me crazy when I'm trying to do it, but
But
it's
you
it's it's still a science that needs to be looked at, and which I still play with. But yeah, but I'm going too far. But go ahead.
all right, engineer. I just wanted to, before we go on, I just wanted to respond to something that you said, and it's pretty interesting because now they were talking about how technology has advanced so much, specifically when the metaverse, like that trend was going on, and they were talking about how they could essentially download all the data that they have of people and then be able to predict with pretty high accuracy like what they would be interested in. Like if you go to one website on your phone and then it shows up on your computer, even though the two aren't necessarily connected.
I always doubt that, and I always anytime me and my professors we always are laughing about this. When I talk about predictive models with humans, everybody start laughing and saying, "Don't try it. It's the
Mm.
most complex. Even unless you know what that person's activities is day to day. Yes, but you don't. You don't know what
Well,
that person is feeling.
they are kind of doing it though, engineering cannabis. If I
But
got up in here, what's up, Professor Black Guys? What's
What's
up,
going on, man?
engineering cannabis?
but they're doing
Uh,
it, but not with they're doing it, but if you look at the models, the
They keep
efficiency
detecting.
rates,
yeah, I'm not. Yeah, I'm
it's
not
not
saying they using the models.
yeah.
They using however they do these algorithms for these advertisements and
Oh,
stuff.
they do it. No,
They've been doing this
no,
crap,
no, no.
bro.
Yeah, yeah.
Like to sell products and stuff. But let me let you finish, bro. I'm sorry.
But no,
Go
no,
ahead.
you're right. So the way when I started modeling humans, I utilized the five senses. That's the basis you start with. The five senses. Your smell, your touch, your eye. Those are the five influences of every human. You start with that basis. Then you start building your models from there. But the problem is those those bases are also intertwined, meaning what you smell and what you see might influence what you feel. What you hear and what you smell, all those all together can influence what you might do, your actions. So how do you gather all that data at once and say with an accuracy what you smell, what you saw, what you heard, what you tasted will predict that you're going to eat a burger in the next 2 hours? Taking all that data with an accuracy, and now you don't even know that you're feeling at that point. So you're taking all your five senses, what you smell, what you eat, what you do, taking all that data you do and saying, with all you've seen and what you've heard and all that, I predict your actions in the next 3 minutes. But I can say again, with a 30% or 50%, maybe if I show you this or this, you might want to purchase that. But again, it's the accuracy rate for most models, especially with humans, is low. It's
Nah,
too
you
low
right. Nah,
because
you
you're
right.
trying to predict a lot of information that influences an emotion that we don't even know what that emotion, how that emotion influences. For instance, even in basketball, that we know we can take predictions on how you jump, all that, but the feeling in terms of how do you inspire Michael Jordan, who is sick as a dog, to hit 20 shots, knowing you have all the data that says he's sick, he's not, but he still comes out running and hits 20 shots. You that emotion, how do you quantify that? That's the problems I'm having right now. How do you quantify emotion? How you quantify when smell, all that goes into emotion? If you can quantify that, that's money. But currently, right now, I'm again psychology. I'm reading psychology, economics,
Mhm.
looking at all that to play and saying, how do you quantify a human emotion? Do you quantify it with all your senses and how those senses influence your decision? Again, these are questions. Again, these are a lot of research questions, but these are stuff that's been looked at, especially within models itself.
Yeah, I wanted to bring up that kind of goes into sales as well. Like nobody buys anything unless it has some emotion attached to it. I remember when I worked at Ronstadt, I worked on their internal ATS system, their applicant tracking system, and even as a data engineer, even though like my role was just to provide the data to the model for the data scientist to work on the actual model itself. There were still chances for me to work on the model, and the whole overall goal was to help people to get jobs. And we used the model for predictions, and using that for predictions for search and match to be able to help the recruiters be able to source talent more efficiently. Um, One thing I've realized is that something that you said earlier, engineering cannabis, is that sometimes like even the people who work on the models don't really know how to what's going on. That's something I realized. Like
Yeah.
some of the data scientists, they didn't know how to like change the Python code.
No, they don't.
And uh,
Some
and
of it, yeah.
mhm.
Some of them,
it,
no, they just because again, Sage, AWS is giving them a cookie cutter model. Like, hey, here's the model, just utilize it. But most data scientists I know right now, they don't understand the mathematics behind it or anything behind the model. So
right,
they just take a cookie cutter model and say, we're going to train it, and what it spits out is going to accept, but without
right,
actually knowing what it entails to build a model from scratch. And that's what's going on currently. It's not even understanding. Right now, I'm talking about parameters and all that. It's what even right now the biggest problem, one of the biggest issues. If you look at one of especially with poisoning data, is look at the dating apps. That's the biggest. You can see that's a big example of poisoning because people supply their data, meaning they supply okay how they look and all that, and some of it is false. It's biased because they're lying. They're saying they look like Serena Williams or they look like Shakira. What in real life they look like something else, and they supply that data, and the algorithm looks at that data and said, okay, she says she looks like Shakira, and he said he looks like Superman. Why not match them together? But their data is false. It's poison. It's lies. So that's a big example of poisoning data, and the algorithms poisoning data. So this is what's going on in terms of data and data science and all algorithms and all that. There's a lot of issues with it, but hey, we still
Ex-
it's still effective.
Excuse me, engineer cannabis. So I've been listening to what you're saying. So basically, human involvement in AI models make it consistently inconsistent.
Yeah, makes it complex and inconsistent. Yeah, because again, we're humans. It's dynamic. It's everything we do is ever changing. It's not we're not consistent. So what we do and what we do changes based on again emotions. And what's the driving force of an emotion? We don't know. Again, we might speculate that driving force of emotion is basically all the five senses. That's speculation. And what five senses drives your decisions today? Is it your sight or your smell or that or both? Again, human interpretation of models is it's again highly ineffective, but they do it. But again, once a human is involved, I hate touching those kind of models. I have to, but once it's involved, I hate touching those because it's so dynamic, it's so ever changing that I really don't want to deal with it. But a structured approach, for instance, if I want to know a mountain has, oh, it's basically going to how a mountain is going to look in the next 10 years, looking at weather conditions and all that, I can predict that even though it's the weather conditions might change based on again human impact, environmental impact from human impact from pollutions and all that. That again comes into again human interactions, and that will change the weather, and that implement impacts my how the formation of a mountain comes in. So see the complexities. I can't accurately predict how a mountain will look like because human interaction and pollution and environmental change will impact how the weather looks like, and then impacts how the mountain will change. But I can look at past data and I can do all that too. But again, human intervention in everything makes complexity of models. I'm giving a lecture. I'm sorry. Go ahead.
No, you fine. You fine. You fine.
You
We
know,
we
engineering.
go ahead. Go
I was
ahead.
gonna say, engineering candidates. It really reminds me of when I was talking to some of the engineers at Microsoft. Man, it's like some of them are extremely like just brilliant. Like they just can understand a lot of the underlying algorithms that make up these models. And it's interesting because I think about how can people even get to the point where they, like, even engineers, technical people, can even understand some of these things, because this is, it gets really deep. It's a whole rabbit hole to
Oh,
kind of understand all
the,
this stuff.
it, understanding bias, for instance, understanding bias alone, it took me a year or 2 years. I'm not even understanding fully. I'm still wrapping my mind on understanding just the bias of an average. Understanding the mathematics is easier, but understanding the data source bias, that's the big complexity. Understanding the
Hmm.
source data, understanding where that data is, understanding how that data is influenced. That's the big problem. The big problem is not the data itself, the model. The models are mathematics. That model classification, regression, clustering, it's even the deep learning, all that's a mathematics that can be looked at and trained and done. The biggest aspect is the source data.
Hmm.
What are you training your model in? The model, the data is what's coming out. How is that source data looked at?
Oh, you know what? That came up. Like that same situation came up recently, where I needed to figure out why the data was taking so long for it to come through our pipeline. Like,
Mm-hmm.
so we needed to like deduplicate a lot of the data, and we were using row number logic in order to deduplicate the data. And then everybody said, "Why use row number logic when you could just figure out what's going wrong with it, where you're getting the data from?"
Data source. That's the biggest
Yep.
issue. It's the data source.
Be right back.
From from understanding how the data source is looked at, understanding why you need that data source, understanding the objective of the data source. It's again everything in terms of the models and all that is beautiful, but understanding why you're predicting something or understanding what you're predicting, understanding where you're getting that data from, and understanding the influences of that data, the parameters, all that is a big key part in understanding your model itself. Again, when we're training models to predict what someone will like, that's what most companies like Facebook and all that, what advertisers need to push to you so you might buy what they buy is based, they're training it based on your watching. What have you been watching on Facebook over time? They can put in front of you and say, okay, this person likes watching gun shows. Do we put something in terms of guns in front of him or ammunition related stuff, camels, or or secondly, what that individual is watching? Are people around him who are watching it, what are they interested in? And can we recommend what they're interested in to that person? So there are many scenarios in terms of understanding, but it's all again the data, source data. What are you getting, and what's the objective of that data you're getting from? And that's how it is. Again, I'm giving a lecture. You be, well, let me let other people talk.
No, you good. Like I said, we were coming up to the end, so that's the part where you came up just in point. Long story short, just real quick on the screen is AWS has a couple of new certificates, like everybody else. They trying to jump on that AI bandwagon. So you see their new AI practitioner foundation. That's just super high level, just to get your feet wet. Then they came up with the what was the other one? They had machine learning associate. You see right there's beta, right? So associate, I think they want you to have a couple years underneath your belt. Then they have a specialty, which is weird. That's machine learning engineer beta for the associate. Then they have the machine learning specialty certificate right there. So like everybody else, they're jumping on it. Then a lot of times, shout out to B2B. they got data engineering associate because a lot of times you got to feed the machine learning. So get your data engineering associate with your machine learning. Just kind of get your toe wet and kind of like engineering candidates. AWS gives you these services so you can get your feet wet. But a lot of times they hide the complexity of really what you're doing. So that's a double-edged sword when you're doing it. But so once again, they had a few machine learning certs out there that they're pushing and want people to get in there. Um, like again, they're machine learning associates in beta. So I think it's 50% off when it's in beta. So a lot of times people think it's easier to take the beta. I got that on my list to get, but hell, I got some other stuff I need to get before I get that one. So
Yeah, I'm trying to get some too. Hey, let's keep you techie talk on some of this stuff too.
yeah, I was gonna let him get in. What's up, keep it techie, man?
What's happening, fellas? How y'all doing, man?
Man,
Yeah,
doing
you
all
good? Hey, engineer cannabis, bro. I love listening to you, bro. Like you
me
putting out
too.
some great information. So that's why I just let you keep going, bro. You know what I'm
I'm
saying?
sorry,
You
it's
actually
my
work
fear.
on this stuff, 100%. Where you
Yeah.
work on this, you know what I'm saying? So it's, I'd rather let the subject matter experts speak
Yeah,
on it. You know what
facts,
I'm
facts,
saying?
man. I get
So
Nah, once I get into it, I just go professor mode
yeah,
on this. So nah, I'm good
no, I
now.
know how it is, bro. Like especially when it's something you know what you're talking about. You know what I'm saying?
yeah,
You get excited about it. You want to explain it, and that's what I was gonna bring up. Like, has anybody played around with any of the open source tools that are out there, the LLMs that are out there?
Yeah, the
Like
bird,
I've
the
been
bird,
recently playing with Olama. I did a video showing people how to set it up and on a
Linux.
yeah, on Linux and everything, and it's super cool. You know what I'm saying? And you can play around with the different models, and they got models out here for any and everything you could think of.
yeah, yeah.
Yeah, so yeah, I did play with some birds, a lot of open source. I've played with a lot of open source, and again, why I play again, I've learned how to deal with open source, and also learned how to build my own from scratch. Because
Okay.
again, if you want to train a model, especially for a specific objective, using a cookie cutter method, again, like B2B or you got when you use, for instance, a generative AI, you have to go to the explain it to, again, in some government agency, to the court or a lawyer. Like, how do you know when? How are you going to use all this? Explain this to me. And the problem is, if you don't know how to basically build it, you can explain how to do it. And at that point, nobody's going to allow you to use it. So
Yeah.
I've learned how to build it from scratch. I mean, so that I can explain how it works intimately, meaning from the data source to how to basically catch biases and all that. I'm explaining it, but some of this stuff, some of the open source, you can't explain it because they're not going to tell you what data they use to train these models. They're not going to give you that.
Mm-hmm.
No open source will tell you, no AWS, but nobody's going to give you the data and say, hey, this is the data source I use to train my models. No, they give you the trained model and say use it. But when you go to explain, okay, how did you train this model? You can't explain that because you said I used an open source model and I wasn't involved in training this model, so I don't know what data they used to train it.
Well, I
So
thought that was
why
the proprietary.
it's
The
proprietary?
open source. No, what I'm saying is, I thought that was the proprietary models that are out there that you don't know where the data actually came from. Like for
Yeah,
instance, we know Meta. They throw one out there that's open source, but we know where that data is coming from. You know what I'm saying? Just by what they do all the time.
but do
Meaning
they give you?
taking all the information from, and yeah, you're not getting a copy of the data,
That's what
but
I'm saying. Because
but
again,
open source though, the open source copy certain ones what's the other one? Open chat, that's fully
Llama
open
3.
source. Oh, I'm
okay.
sorry. And was it Llama 2, Llama 3? That's fully open source.
So do they give
Everything
you?
is there on how they actually built the model. They got white papers and all that stuff put out there breaking down how the model was created and what data they use. So I mean, I'm just speaking to that specifically.
Because
I
I was trying,
understand the other ones.
yeah, because I was trying to, because some of the ones I've used is because they will ask you what
Hmm.
data did you train it with, and how
Yeah.
is that data continuously trained, and what's confidence do you have in terms of that? And yes, if you get that source data and say, oh, this is what it's being trained on,
Hmm.
that's good. Then at that point, you can ask yourself, if this is being trained on this data, does it match my own data set? And most likely it doesn't. Most likely, okay, you want to classify different animals, but your data, your algorithm is trained on classifying humans or
Hmm.
classifying that. So you can't use an algorithm that classifies human to try to classify an animal. So you see, some of my objective might be so specific that it doesn't fall in terms of those algorithms. So I have
Okay.
to then learn how to train mine differently.
No, you're right. You definitely should get in there and learn how these models are made. I know I
Yeah,
was looking at a video not that long ago, and I meant to go back to it. I bookmarked it on Free Code Camp, where someone walks through setting up a model from the base level, like
yeah,
how to actually create the model,
yeah,
all the parameters and all that stuff. So
yeah.
the information is out there,
No, the
and it's
information is
good
there.
to go through and try to learn it,
So yeah,
like you're
again,
saying.
so I learned all that, how to create that, because the question you might ask is so specific that it might not contain into where the open source model is being trained. So now you have to go back and train your own model. So that aspect is there. So again, I said the human is always changing. So
Hmm.
you might have to learn how to train your own model to do what you specifically want to do. So it's depending on where you are, what objective. Again, now we're looking at quantum. It's gonna have more complexities in there with all that. So it's 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 getting where it's complex, and we need more people. But again, I've been a champion of this, but I'm trying to champion it more. But the complexities are in there. It pays well, but there are a lot of complexities in this, especially even the cybersecurity side. I still work with a lot of cybersecurity experts to actually understand this. Yeah, that's it.
Yeah, I'm over here. I'm still trying to understand everything. I just learned about RAG recently, like back in April.
Yeah, shout out
Oh,
Bit Navigator. Shout out to Keep It Tech. He said he went flown full blown Alama rag and build agents, man. Keep It
yeah.
Tech, he got a movement going on out here. Shout
but the
out Keep
Linux,
It
Yeah, man.
but Linux is the most compared to Microsoft in operating systems. Linux are it's the most adaptable, especially with
Yeah,
large language models, neural networks. Linux to me is the most adaptable operating
facts,
Now,
system for that, and
facts.
that's what
now
I use.
let me ask. Isn't so because and I'm sure the Keep It Taking can kind of help me with this. Is that isn't Linux a kernel?
Yeah, that's correct. Linux is a kernel, and they have multiple distributions. And basically, the distribution, if you look at it this way, Linux is the kernel, it's the base level. You can you can it can be a front end, but most people don't use it as a front end. I mean, you can look at it as the back end of the operating system nowadays, because they put desktop environments on top of Linux itself, and then they call it a distribution. That's essentially what it is, just to make it simple.
But to deal with most of my deep learning approach, especially neural networks, Linux to me far surpasses Microsoft in terms of operating systems. Especially when I'm dealing with deep learning approach, neural networks,
Mhm.
Linux is my
Yeah.
go-to
It
compared
isn't
to.
it that because they even had Azure based off of Linux, and I remember somebody at Microsoft getting upset with one of the engineers for
Steve Ballmer.
choosing to
Steve Ballmer got upset with
use Linux.
yeah, Steve Ballmer almost fired your boy, who's the president now when that first came out.
Yeah, they and it's crazy because now Amazon has their own Linux distribution out there. I think I did a video showing people how to install that. So it's out
Yeah.
there. You can download the
Yeah.
whatever, however I download it. I don't remember the exact process, but I got the process out there for anybody that want to try it. And I think Google, they have their well, Android is Linux, but
Yeah.
Google, you can install whatever distro you want on there. You can even upload ISOs, and then a lot of these other cloud platforms, they have Linux options.
Yeah. Amazon's a fork of Red Hat, right?
Yeah. Yep.
Mhm.
To be
Yeah.
honest, I just use it when I lab now. I just do my labs on Amazon, on AWS. So I just spin up my whatever I need in my Amazon VPC, wire it up, test what I need to test, and shut it down. Go ahead,
Yeah.
BP.
I was gonna bring this up. I wanted to ask the question to everybody. What are your thoughts on the Amazon president talking about Amazon Q and how they've been able to save, I think it was like 4,500 engineering years,
Mm-hmm.
and they were able to generate so much more revenue in um, making up on that productivity that they would have been losing if they had not used the AI tools. What do you guys think about that?
I just think that's the future, right? I think, and I said this a number of times, is people aren't getting fired. There's such a shortage in security programming. So, and two is I actually just went to a demo with the AWS guys, and they just use it as assistant. He created a quick website built on React and I think Python, and it it generated more like scaffolding. He had probably 80% of it there, and he just filled it in, right? So he had that program. And I just think it's the future. And it's just an assistant, right? It's not.
Yeah.
So go ahead,
It's
engineer.
it's not everybody. There's too much hype in that. Like AI, it's gonna revolution take it. Nah, again, I don't trust AI fully. Again, I build AI models, and I've seen the inner workings of it, and I will tell you, nah, it's not. It's not there yet. It's the adaptability aspect of it. Again, it's not in there yet. The ability for an AI system to adapt quickly to ever changing situation is not there. You have to
Mhm.
feed it data to quickly adapt. Even in reinforcement learning, the ability to teach a robot to look at its situation and then reward it based on, again, that's reinforcement learning, the ability to teach. But again, you have to teach it in terms of the environment. If it has not experienced that environment, means it's not going to learn. But a human like us, we try to adapt quickly based on, if it's a new environment, we try to adapt based on what we know and our anything. But again, with an AI system, you have to teach it. If it teach it by learning from experience or teach it by learning from data. But you have to teach it by feeding it something. If you don't
Yep.
feed it, it doesn't learn. So
You
the
know, can I?
question you can how does it adapt if you don't feed it with new information or anything? So that's one of the aspects where people say AI is going to take over, but if you don't consider the adaptability part, then you understand that AI is not going to take over.
Mhm. I agree with that statement. I'm gonna let me respond to this real quick, and I wanted to respond to what Engineering Cannabis said. Um, so yeah, Bit Native. It's interesting he brings up Claude because I saw that Claude was ranked, or Claude AI, the LLM was ranked as the number one LLM for coding, and I agree. I think is actually really good. The only thing is I realized that from the free version, it's actually you get less queries. What do you call it? I think it's called queries prompts with Claude compared to ChatGPT for the free version for like ChatGPT 4.0 or something like that. But yeah, so I think that Claude is actually really good though, based off of what I had a project I needed to work on, and the code that it produced was way better than ChatGPT and Gemini. You know, but yeah, so everybody like they all have their own strengths and weaknesses. Um, yeah, and then what engineering cannabis said, I think more specifically about AI not being able to take over. I think that it's going to be way too expensive for companies to fully replace engineers with AI. I mean, not only financially, but then also um, the cost based on on our environment. You know, because like I remember, I think PBO you brought this up before about how they had to create nuclear reactors in order to just cool down the computers that were running some of these prompts from these LLMs. You're on mute, PBO.
Yeah, if you look out there, the data center, when you run AI, they were eating up the data center resources, and just trying to cool a data center was just kind of astronomical. So they're trying to
Mhm.
get a hold on it. Cool thing though is a lot of people creating their own chips to try to, I guess, figure that problem out. Yeah.
With
Yeah.
this question, this guy just stated that with large language models have not they're not there yet in terms of sentimental analysis, sentiments. So, for instance, if I say I want to hit somebody and the person I didn't have that intention, a large language model can't perceive that as being either negative or positive. It has to take all the a lot different data sets to either perceive that that was negative or positive. So if I say I want to slap somebody, but I don't have my intent emotionally wasn't really to slap the person, how does a large language model capture that intent?
I
It
think
does
he's talking about programming. I think Big Nami's talking about the programming aspect, generating code from that basic standpoint.
because I know because a lot of in terms of large language models,
Mm-hmm.
they're far from perfect, especially dealing with
Yeah.
sentimental analysis. They are far from perfect. Understanding again human emotions, sentiments in terms of your action and your emotion attached to it. There, I was
Mm-hmm.
looking at other ways to do it, but you can't just do it just by saying someone saying, "I'm gonna hit you." That sentiment, that emotion in there. How do you figure that out? There are a lot of data sets from you can use to say, okay, based on how his face looks or how they grind the teeth, and then mix with the words and all that, then you can say, okay, there's a driving force on that. But without that, just saying with one language, I'm going to hit somebody, that sentiment, that emotion is not there. So you can't say if that's a negative or positive. So sentimental analysis, especially with large language models, they're far from what it is. Because if you could, they could use that as a lie detector test. But right now, you can't use large language models. There are a lot of variables you have to account.
Right. And then it's so many compliance issues that come along with it as well. I know PBO, you talk about compliance a lot. And and with AI, you know, you can't use it for like HIPAA regulations because you can't just look up on Chat GPT somebody's. I think also engineer cannabis. You brought this up earlier. You can't use it to diagnose people of a certain problem
Mm-mm.
because you know you can like I think you said you can use it as like a second
As,
or third
yeah,
opinion,
opinion.
but then
But no, never
you
use
still
it to
can't.
diagnose it. No.
Yeah, you still can't because you're essentially feeding that data, right? You
Yeah.
said you had to feed it something. Now you're feeding people's personal information to an
Hmm.
AI model, and then you know if they and then that stuff can be brought up.
And that stuff could be biased because you might feed it, for instance, sick. You want to feed skin cancer, but you're feeding your models skin cancer, detecting skin cancer for black people, and you're using the model to detect skin cancer for a white person. You see what I'm saying? But the model was trained to detect skin cancer in a African American person, but you're trying to use that model to detect. See where that problem comes in? It's the bias in it. So again, it's there's a lot of issues. That's why you never rely on a model. You use it as a baseline. Okay, this is what it's saying. Can I build on it? What other analysis or the data sets can I use to basically either confirm the confirm the model is true or what other stuff I'm gonna use? So there are a lot of ways to do it, but it's a baseline. Never use it as a true detection, but use it as a baseline, either to build it's either true or it's not.
Yeah, man. I think that it's really interesting to see how people are going to be using it going forward. Um, I use AI pretty much every day. Just not only for work and everything, but just if I had to ask a quick question or something I really need to know, or even just to like strategize for like business.
AI is going to be part of us. It's given now. It's going to
Yeah.
be in our everyday life.
Yeah.
It's
Yeah,
already is.
Yeah.
The
because
question is what extent.
Yeah. Yeah.
yeah, it's big when older people know what it is.
Hmm.
Yeah.
So it's a part of our daily lives. But the question is to what extent and to what trust? How much trust do we give these AI?
That's
Do
it.
we give total trust or do we have a limitation on these AIs? Again, I build
It should
models.
be a
This is what I do.
limitation. It depends on what environment you're working in too, because like it tripped me. I was I was tripped out, man. I was on a government call. Somebody shared their screen. They had Chat GPT in the background
See?
already open, and I'm like, nah, you're not supposed to be at that site. Sorry. Yeah,
Mhm.
and you shouldn't be. And if you putting sensitive information in there, anybody they had a hack a while back, right? Someone got
Yeah,
into Chat GPT and got all the user data out of it or something
yeah.
like that. So yeah.
So the question is how confident do you need to put your real life situations, a surgeon or something, how confident should it be something you put, or do you say, oh, this is a 10%, the AI is going to be a 10% decision maker or 20%. We'll use it as a baseline, but we need to understand other factors that affect it. That's why I said AI is not going to replace people. AI is going to be assistant. AI is going to be a baseline. AI is going to be a second thought or an opinion other than, oh, I'm a doctor. I say this is leukemia. This AI says it's a different kind of cancer. Okay, we need to either test to know which is true. If it's the AI, okay, what did the AI see that I'm not seeing? So these are it's analysis. It's understanding the data sets and understanding what's new and going from there. So we're not the goal again. If anybody's saying AI is going to replace the person needs to understand how AI works and understand that nah, AI is far from where it's going to replace it. It can adapt emotional aspect. There's a lot of aspects that AI can't do, but AI can do a lot. But again, there's a limitation on what AI can do. So that again needs to be in everybody's back of mind that AI is not some kind of ultimate technology that's gonna. Nah. Again, if anybody's saying that, that person doesn't understand what AI is. So this is it. But thanks, man. I gotta go study.
Yeah, go ahead. I was gonna give you your last comment for you cut out engineering Cannon, so I'm about to shut it down. I'm tired
Yeah.
too. You got a
Sorry.
last comment you want, man?
Yeah. I know I've been gone. I'm supposed to be, but there's a lot of stuff going on, and I'll start coming back on YouTube and explaining all the good stuff in terms of what's going on in AI. But it's a good stream, especially within the security side, because nobody's talking about the security in AI.
Yeah.
Since AI is growing, they need to understand the security without that. How again, how AI can be vulnerable. We're putting AI in cars, and we're putting AI in robotics. We're putting Chat GPT, we're putting all these AI, but nobody's talking about the vulnerability part. How each aspect can be vulnerable and how
Mhm.
they can lead to a lot of problems. And this is a great topic. And kudos to you for talking about
Appreciate it, man. I'm glad you came out of hibernation, man. I was wondering where you was at, man.
that. Stuff
Thanks.
got to
Excuse me,
go.
PBO and
Yeah.
engineering candidates. I know you have to go and study. I understand that importance. So get it hitting the books. I have a quick question. when it comes to machine learning, AI, and autonomous commercial vehicles. Um, I guess my question is, how come companies like Too Simple, Kodiak Robotics, Aurora Innovations are having more success with semi trucks than cars?
Semi trucks and cars, again, it goes back to the objective. Semi trucks, the logistics in there is we're going from point A to point B, meaning it's mapped out. One location, and we know the cargoes, we know the parameters around that. So it's, again, and we're removing the human aspect of it. So we know every parameter is, and we know we're going from point A to point B. And within that point A, point B, we know what's happening within that. So it's more of a structured approach. So it's more of a predictable approach rather than in commercial vehicles where we don't know where you're going from point A to point B. We don't know if your Uber is going to pick you in New York, in Brooklyn, and going somewhere else. We don't know point A to point B. It's dynamic. Remember when I said the human aspect is of it? A dog might come in there. We don't know what might happen. Something might happen. Another driver might hit you. We don't know. There's no predictability in this. It's so dynamic. But with the semi truck, there's a little bit of predictability. Meaning we know we're going from point A to point B. We know these are the cargoes we're going to try to deliver. We know some structured settings we can control. There's a little bit of control in there. A little bit, but not total. So that success rate is based on the little bit of control they have. But with the other aspect, there's no control. If I want to build an autonomous vehicle for Uber, I'm going to have to take in consideration everything going in there. But again, human. I told you a human aspect is going to be in there. Someone, bus of children going in or crossing the road, or a dog just running through the road, or something. There's something in there. There's no controllability in that point. You don't even know what destination you're going. That's another part. Uber, you don't know if you're going point A, point B. You don't. You have no true control over that. But with the semi trucks, you do have a little bit of control in it. You have the destination cargo. You have all these controls a little bit, not total, but you have a little bit you can control. That gives you that little bit of success rate, and that's why I believe it's more successful. Is the control part. It's not the technology and all that. It's the control.
Yeah,
If you look at,
it is
yeah,
Thank you. Thank you.
it's very unpredictable though, like you said,
yeah,
you know what I'm saying? Like, I don't know if you seen that video. There's a video circling around about all these cars, because you know they got the autonomous cars running in, what was that, San Francisco,
Yeah,
yeah,
San
where
Francisco
they
and
was just
Arizona,
sitting
I think.
there,
Yeah.
yeah, and they was trying to park for the night, I guess, to
mm,
get their charge and stuff,
yep,
and they were just stuck there trying to back into the spots, you know, correctly and all that stuff. So it's a lot of stuff they got to work out with that,
yeah.
you
So
know.
it's a lot of it's the commercial part is there's a lot of
Not Now the commercial part I wanted to speak on is other issues that yeah, you're right, it is predictable a little bit, because it's going from point A to point B. This is
yeah.
the route, this is where
This is
you
the
go.
route
The
logistic.
problem is when it comes to AI and uh autonomous vehicles, uh it's the batteries and all that stuff. Now if they run
Yeah,
diesel, you know, that's fine, but the batteries and all that is gonna cost the load to be heavier,
Yeah.
so you can only carry so much stuff, so that's gonna affect it right there. That's one problem. And as well as the batteries not being able to make it, you know, as far as they can. You see what I'm saying? And I
but
think they're looking into hydrogen or something
yeah.
like
So
that
so
or
those
whatever.
problems can be, again,
Yeah.
especially with the loading part. You can have a set say, okay, this is going to be what it is. If you deviate from this going all that. Yeah, that can be controlled too. But again, they have some control. That's why it's successful. But with, again, the other side where there's no control, you
Mhm.
can't. do anything with it. You will be unsuccessful. Again, I always said, when you put a human in this, especially a human that you will have, there's the success rate will drop drastically. But when you can have a little bit control, just a little bit, you see some success in it, and that's the problem. It's they have a little bit of control and they can see. For instance, if Uber now has a lane on its own, just create a whole lane where they don't interact with humans and all that, you will see a success rate. But again, you can't have that. And that's why autonomous vehicle, especially in the open road, there's going to be a lot of difficulties in that.
Yeah. And PBO,
Yeah.
I know you probably looked at that link and was like, what the hell? Did
I
Keep
ain't
It
look at
Techie
it.
send me? Oh, okay. I sent
I
you
ain't look
something
at
in
it.
the private chat.
I saw it. Should I go to it?
That's if you want to. I mean, it's mine. It's
Okay.
my server, but
Okay.
I was just gonna share
Yeah, I can share it.
LL, one little
Yeah, I'll do that.
open the Olama.
Yeah, we trust you. Keep it taking.
Okay. And I
Hmm.
created did it pop up with the site? Or
Now I
no?
said can't find the page. Let me see.
Hold on.
Did I do something wrong?
Hold on. Let me
Hold on,
put it
try
this way.
Let me try again. It could be me. It could be me.
You got the name server.
What browser should I be using, man?
It don't matter. It should all work. Hold on. Let me see you this. Let me see you this link. This will probably work.
All right. Whew. I'm running out of gas, boy.
Yeah, I know you trying to get
Okay,
out.
yeah.
It came up.
Yeah, you can bring it up, and I can give you control of the screen or however.
Oh well, I didn't know if you had time for that, so I was
Yeah, go ahead.
But
go ahead.
all right, let me share right fast. Hold on.
Sure. It's cool.
Let me know if you can see it.
Let me see. I just heard it. But I'm trying to get used to my new restream. They done changed it up on me. There it is.
Okay. Yeah. So this is, essentially an open source, and I created a little BS account in there. It's not the admin account. I was gonna give it to you so you could show it. But
I was gonna let you do it. You good?
Okay. Yeah, I got you.
You
And then what is it? Test 1, 2, 3, 4, something like that. And I'm deleting this after this. So if y'all hear the password and all that
you
stuff,
better be careful, man. People try to set you up, man. Have to be malware on it.
let's see.
Right, your own server.
Nah, this ain't my personal server. This is it is my personal server, but I'm just saying it's in the cloud.
No, I feel you.
Gotcha.
Yeah, and all I gotta do is delete the virtual machine. But anyway, you can do the exact same thing as Chat GPT for free. I'm gonna just say testing.
Oh man, I gotta do that.
Oh, it's not working. Oh man, hold on. It was just working. What the hell?
And then it told on you.
Yeah, I know, right?
You know how it is, man. When you
when you about to show it,
it'd be pressure on you.
Okay,
all right,
well, never mind.
Got cold feet.
But hold on, I can go into the. Let me go into the to the admin account.
You got nervous, man. You got cold feet.
It's
interesting because they say that most people, when it comes to public speaking, most people would rather die than go up on stage to talk to people.
Oh, yeah.
Nah, that's true. Yeah,
that's true, man. The two is it depends on the little audience, man. I know people scared to get on YouTube, man. I'm like, dude, it's just me and a couple of my friends chatting it up.
Oh man, I met a few people like that. They were like, "Oh man, you do YouTube? I couldn't possibly do that."
I know,
nah, it took me a while. This thing ain't working no more. Okay, whatever.
We have to do another video.
Yeah, it's all good. I'll show you one.
Nah, that's
trying to keep a brother down.
But
keep a brother down, man.
But you can set one of these up, no problem. Okay. Oh, I'm sorry. Go ahead.
No, you good. Just real quick on Shungo, what he brought up is, and because I sent him a video, what the semi industry did for autonomous. They said driving from the highway up to the freeway is going from B to C is the B route, and C is driving it back into the city. So what they decided to do is a person's going to drive it up on the top of the highway, Autonomous is going to drive it on the other side of the country. Then a person's going to drive it in the city because that's the hard part, right? So if you look at a lot of the big autonomous car, they were just going to try to take out the B route, which is most of your money, right? So they're going to take all that complexity out, like engineering cannabis say, the hard part. Because driving on the highway now, if you look at your Google map, tell you straight where you're going, it's telling you exactly when you need to get off. So I think that part from autonomous trucking, they're just gonna start just using the driving on the highway part. So, oh shoot!
Thank you, PDO.
You welcome. Go ahead. Go ahead. Keep it techie. I'm gonna let you get the last shout out on that one. I'm gonna shut it down.
Oh no, that's all I got, man. Hey, appreciate you letting me on. PBO, yeah, and we're gonna have to link up again, do another live stream, bro. Where I can bring you on and see where you at with all these expert AWS search you've been getting. You know what I'm saying?
I've been trying. Yeah. Anytime, I usually your backup guy. When somebody don't show up, just shoot me an email. I'll be there.
There.
I appreciate you. Go ahead.
Yeah, no problem.
I'll give you the last one, B2B.
Yeah, PBO. I appreciate you for having me up as always. I'm glad that I was able to contribute in some ways, man, especially when it comes to data engineering. I'm like, because I actually did work on a few of the AI projects, and my work went directly into the AI.
Yeah.
So I kind of knew where it was. So it
feels
right. It feels good to have impact.
Yep. You data preparation. You right there getting it ready to flow over in the model. That's you, man. The data preparation. So
right, definitely, man. And I've actually had to do some development in the AI model. And I think they were using Vertex AI for deploying their model. But yeah, man.
I think I'm gonna use SageMaker because you can use it for free for a year. So I think I'm gonna kind of play around because that's their model that you can generate models and deploy models, and like you said, the part you talking about data preparation and getting into SageMaker. So I think I might use SageMaker. You can use it for free, and I was going to actually use the GRC as models using different companies to kind of figure out from a compliance standpoint, and trying to build some models off of that.
Sounds good, PBO. Well, I don't want to hold you up any longer.
Yeah, old people going to bed, man.
Appreciate y'all for having me up here, man.
I appreciate it. Thanks for coming up, Shango. I'm sure we're going to chat later, man.
No problem. Appreciate you.
All right, everybody have a good night. I appreciate everybody joining me. Ooh, old people tired, man. I'm going to take my butt to bed. Once again, thanks for joining me. Let me see what's in the chat. See if I'm missing anything. AI equals awesome. Nice. Don't delete it now. Facts. Demo gods attack facts. Facts. Let's see if we get in there. Yep. Facts. Great stream. I appreciate it. That's true. Hopefully everybody have a happy hump day tomorrow. Let's get it. I used to use Google Driverless Faculty. Wow, that is cool. So yeah, I was gonna there's a remote car that you can do that on AWS. So I was trying to do that to get young guys motivated to get into tech and cybersecurity. So I'm thinking about doing that, Aiken. So that's on my 1,000 things I need to get done. Once again, PBO, thanks for joining me. I'm out. Check the replay. Reach out to me, ProfessorBlackOps@gmail.com. I'm sure we'll link up.